Hello everyone, welcome back to the channel. The Strait of Gibraltar is one of the most iconic and strategically important stretches of water in the world, separating Europe and Africa by just a few short kilometers at its narrowest point. It's a place where the Atlantic Ocean meets the Mediterranean Sea, where cultures have intersected for thousands of years, and where trade and travel have flourished for centuries. Yet, despite this relatively small gap, no bridge has ever been built to connect the two continents directly. Many people have wondered why such an ambitious project has never been realized, especially when modern engineering has allowed humanity to construct enormous bridges in other challenging locations. To understand why, it's worth breaking down what such a bridge might look like, how it would function, and the monumental obstacles standing in its way. From the outside, the vision of a Europe-Africa bridge is awe-inspiring. Imagine a massive structure stretching over 14 kilometers of open sea, towering steel pylons rising like monuments above the water, and cables spanning distances longer than anything attempted before. The bridge's profile would be sleek yet immensely strong, built to endure the constant battering of winds funneled through the narrow strait and the forces of ocean currents below. The Atlantic's unpredictable waves and the Mediterranean's calmer but shifting tides would create a unique environmental challenge, one that would need to be addressed in every element of the design. It would be visible for miles from both continents, becoming a landmark not only of engineering but also of symbolic unity. Ships from around the world would pass beneath its towering arches, framed against the dramatic backdrop of the mountains of southern Spain and the rugged coastline of Morocco. Inside, while a bridge doesn't have a traditional interior like a building, the inner structure of such a megaproject would be a world of its own. Within the giant support towers, there could be elevators, stairwells, and maintenance corridors allowing engineers to reach every part of the bridge for inspection and repair. These towers would also contain power systems, communication equipment, and possibly even weather monitoring stations to ensure constant operational awareness. Along the bridge itself, hidden within the roadway, there could be service tunnels to house electrical lines, water pipelines, and fiber optic cables, turning the bridge into more than just a transportation route but a vital infrastructure link between continents. Advanced monitoring systems embedded in the structure would track stress loads, detect corrosion, and measure wind and temperature in real time. This would allow operators to address potential problems before they became critical, ensuring the bridge remains safe for decades or even centuries. The performance demands of a Gibraltar bridge would be unlike any other project in the world. It would need to handle thousands of vehicles daily, from private cars and buses to heavy freight trucks transporting goods between Europe and Africa. It might also have to support a railway line, enabling high-speed trains to cross the gap in minutes rather than hours. This means the roadway would need to be exceptionally strong, made from materials resistant to the salt-laden air and constant exposure to moisture. The bridge would also have to function smoothly through the region's volatile weather, from scorching summer heat to fierce winter storms. The two shipping lanes below are some of the busiest in the world, so the structure would need to be high enough to allow safe passage for container ships, tankers, and naval vessels without causing maritime traffic congestion. Every aspect of its performance would be pushed to the limits of current engineering capabilities. Safety would be an equally important consideration. The region is seismically active due to the meeting of the African and Eurasian tectonic plates, so the bridge would need to be earthquake-resistant, with foundations designed to absorb and dissipate seismic energy. The winds through the strait can reach dangerous speeds, so aerodynamic design and dampening systems would be essential to prevent dangerous swaying or oscillation. Emergency response systems would have to be integrated into the bridge's design, including safe pullover areas, fire suppression systems, and evacuation routes. There might also be small sheltered stations along the span for travelers in case of sudden weather changes or accidents. For maritime safety, the bridge would require powerful lighting, radar reflectors, and navigation systems to guide ships safely beneath its spans. The unique selling points of such a project are almost limitless. It would be the first permanent land connection between Europe and Africa, turning what is now a one-hour ferry ride into a direct journey of minutes. The economic benefits would be immense. Goods could move faster, tourism could flourish, and cross-continental trade could reach new heights. It could also become a powerful symbol of cooperation, linking nations in a way that transcends politics and geography. The bridge could even host integrated green energy systems, such as wind turbines or solar panels, turning it into both a transport link and an energy generator. Over time, the bridge could transform the social and cultural relationships between the two continents, making daily interaction far more feasible. However, the price tag is where dreams meet hard reality. Experts estimate that such a project could cost anywhere from $50 billion to over $100 billion, depending on the final design and the technology required. That figure includes not only construction but also decades of maintenance, given the corrosive marine environment. The logistical challenges of transporting materials, working in deep waters with strong currents, and building on such a massive scale would add significantly to the cost. On top of that, there are complex political considerations. Multiple governments, international laws, and environmental regulations would all have to align perfectly before construction could begin. In the end, while the Gibraltar Gap Bridge remains one of the most fascinating what-if projects in the world, it is still far from reality. The engineering is possible, the benefits are clear, but the cost, political hurdles, and environmental challenges make it a dream for the future rather than a plan for the present. Perhaps one day, advances in construction technology, funding, and international cooperation will make it feasible. Until then, the strait will remain one of the most important maritime gateways in the world, crossed by ships and ferries, and watched over by the endless possibilities of human imagination.